this final video, I want to show you a few tips and tricks that will make your life easier and your model look better. We'll start out with dividing a layer into tiles in QGIS. One issue that you might run into is that when you export one of your layers in QGIS to Rhino, the hatch that you get is too big for Rhino to handle it. This might happen if your project area is very large, or if the layer that you're exporting is very complex, like the road system, for example. So to solve this issue, what you can do is you can split up your layer into a few different tiles and feed it into Rhino step by step, so tile by tile. So I'll show you how you can easily do that. We'll start by selecting the measurement tool here in the toolbar and looking at how wide and how high our project area is. So for me, the width is approximately 1000 meters and the height is about 550 meters. And now if we go to vector, to research tools, and to create grid, we can decide how many tiles that we want to create. For me, I think 4 tiles would be ideal. And since our project area is about 1 kilometer wide, we should make each tile about 500 meters wide. So for the horizontal spacing, I'll use something a bit higher than what I actually measured. So let's say we'll use 600 because it's better to have some overlap on the sides of the project. So just use a bit more than you measured. We also want 2 tiles in the vertical direction, and our distance was approximately 550 meters. So divided by 2, let's say we'll use 300, or 350 maybe even. For the grid type, we want to use rectangle, and for the grid extent, we click on this small arrow, calculate from layer, and use our project boundary as an input. And then you can just run, and you get these 4 tiles. So in order to split up our road system, we have to put each one of those rectangles on a separate layer. And we'll do that by going to Vector, Data Management Tools, and Split Vector Layer. For the input, we'll use the grid layer we just created. The unique field, you can leave it how it is. For the output file type, we'll use GeoPackage. And for the output directory, click on the 3 dots, save to directory, and just make sure you're in the project folder that we created. Then you can run it and close it. And you'll see nothing at first, but if you go to the folder, you'll see these new layers called ID 1 through 4. And you can select all of them and drag them onto your QGIS canvas. And now you can see that each one of those rectangles is on a separate layer. So we can turn off the original grid or even delete it, remove layer. And now the last thing we have to do is splitting the road layer with those rectangles. So you do this by selecting the roads clipped, our starting layer, go to Vector, Geoprocessing Tools, and choose Intersection. And then select the Run as Batch Process option. So in total we need 4. So click on the plus sign to add 3 more operations. The input layer will always be the roads clipped, and for the overlay layer we have to choose the different rectangles, ID 1, 2, 3, and 4. And then for the output, click on the 3 dots and make sure you're in the right folder, and let's call this tiles road clipped and say save. And for the autofill mode, use fill with numbers, so it will automatically give each layer a name, and just say run. And again, at first you will not see anything. We can actually turn off all the layers that we used, go back to our folder, and we'll see that there's our new layers called tiles road clipped. 1 through 4. And if you drag those onto your canvas, then you can see that the roads have been split into several tiles. And now they should be small enough for Rhino to be able to handle them. But you only have to do this for the layers that are either very, very large or very, very complex. The second tip I want to share with you is something to make your QGIS folder a bit more tidy. You can see that the way we've been working, we've created a lot of different files, and you can actually keep this a lot cleaner if you use geo packages. So when you create a new layer, as we have been doing, we always went to layer, create layer, new shapefile layer. But what you can actually also do is go to create layer, new temporary scratch layer, and give it a name, for example, test layer. For the geometry type, whatever you want to use, we'll use point, and make sure that the projection system is the correct one, and say OK. And now if we add some data to this layer, a few points, for example, we can right click on this temporary layer that we created, say make permanent, and use GeoPackage as a format. So if I save this on my desktop, for example, and call it data, I created one new file on my desktop, and I can even add more layers to this GeoPackage. So if I create another temporary scratch layer now, this time with polygons, for example, and I'm gonna make this one permanent as well, right click, make permanent, I can actually navigate to the GeoPackage I created last time, data GeoPackage, say save and OK. And now both these layers are saved within that one GeoPackage. So if you delete those and reload the GeoPackage from the desktop, you can see that both layers are in it. And if you select both and say add layers, your data is here again. So that just keeps your folder a lot tidier, and you can use that instead of the shape layer. The last tip I want to show you is in Rhino, and it's how you can use more realistic trees than these abstract ones we made earlier, using Enscape. So if you don't have Enscape installed, then Google Enscape for Rhino and download it and get your license. If you're a TU Delft student, you get a free license. And then you should see this Enscape toolbar in Rhino. If you don't see it, you can go to File, Properties, Toolbars, and make sure that Enscape is enabled, and just say OK. And then you'll see this Enscape toolbar that you can add to your environment. The nice thing about Enscape is that it comes with a lot of assets. If you go to the asset library by clicking on this tree symbol, you can take a look at all the assets that Enscape has built in. And one category is vegetation. And you have a sub tag that's tree. And we can just add those to our project. So let's choose one that we like. For example, this one. And then you have to click on the surface that you want to place it on. And then you can just place it. Let's also use another tree, maybe this one. And the last one. And now you can see we have these 3 trees, and they already look more interesting than the abstract ones that we manually built. But if you open your model in Enscape, they will render as real trees. So let's take a look. If you click on the Enscape start command, then you can see that the trees look really real. So how can we distribute these trees across all the points that we imported from QGIS? Well, let's go back to Grasshopper. And we'll do something very similar to what we did for our abstract trees with a few modifications. One thing that's important is that you have to have the Elephant plugin installed in your Grasshopper. And you can just find that by Googling food for Rhino and Elephant and then download the plugin. Let's start by referencing the trees from Enscape in our Grasshopper document. And you have to go to Elephant, and then you have this extended geometry component. So add that to your canvas and make 3 copies in total. And for each tree, we'll also need a base point, just as we had a base point for our abstract tree. And we'll do that by adding a point container and also making 2 more copies of that. So for each one, we'll reference the tree first by selecting it, right-clicking on the extended geometry, and say set one extended geometry. Do that for each tree. And then we'll draw a base point for each tree. So let's make a new layer, Enscape trees, and activate it. And using the point tool, we can just add a point to the bottom of each tree. Just make sure you have the vertex snap turned on and place the points. So now we'll have to reference those points as well. Click on the first one and right click on the point container. And finally, we need to reference all the points from QGIS. So we'll make another point container and go to our trees layer, right click, select objects, then we'll have all the points selected, and right click on our point container and say set multiple points. And just like last time, we'll use the orient component to place all of our trees. But the thing that's different this time is that we have 3 different trees that we want to distribute randomly across all the points from QGIS. We'll start off by shuffling our points. So double click and look for the jitter component and just connect it to the L input. And now we have to make 3 different sub lists that each contain 1/3 of the points. So double click and look for the partition list component. And it needs a list as an input, which is our points. And it needs the size of the partitions. So we'll use a list length component to find out how many points we have in total. And then input that for the size of the set. And by right-clicking and going to expression, we can add x divided by 3. So it takes the length of the list with all the points that we got from QGIS. It looks how long it is, divides that number by 3, and inputs that for the length of one sublist. And now we can turn all these points into XY planes, like we did last time. XY, the XY plane. Connect them and connect the planes to the target plane input of the orient component. And we're almost done. We just have to input the geometry and the base points for each tree. And before we do that, we have to combine the 3. So let's make a data container and duplicate that. So in our first data container, we'll put all the points, connect it, and hold shift to connect a second one and a third one. And in the second data container, we'll put all the trees. And again, if you press shift, you can connect several inputs to the same container. And we also want to graph those data components. So right click on the component and choose graphed, and do the same for the other one. So the data component then contains all the points. We have to put it into an XY plane. and then connect it to the A input of the orient component. And for the data component that contains all the trees, we can connect that one to the G input. And then you can already see that all the trees are turning into Enscape trees. But somehow they're still not very random. And that's because I forgot to connect the jitter component to the input. So use the V output and connect it to the L input of the partition list component. And then you'll see that all the trees are assigned randomly. The final step is baking them to bring them back into Rhino. So we'll use a geometry container and connect the G output to the geometry container, and then right click and bake. For the layer, we'll use Enscape trees and press OK. And now you can see that all the trees have been randomly assigned to your model. And then if you open this model in Enscape, you can see all the trees are rendered realistically. So that's it. Good luck with your model.